Okay, so a review with radicals. We're going to simplify the square root of 45y to the power of 5 into its mixed radical and simplest form. So take your 48 and we could divide it by its perfect squares, or we're just going to divide it by the prime numbers. So remember the prime numbers are 2, 3, 5, 7, 11. So take 48 divided by 2, you're going to get 24. 24 divided by 2 is 12. 12 divided by 2 is 6. 6 divided by 2 is 3. Now, if I just asked for what the square root of 48 is, the square root of 48, Gabriel, would be what? Yes, it'd be 4 root 3. And remember that this can be confirmed on your calculator. So from 10C we did this. You could type in the entire radical, square root of 48. This is equivalent to a mixed radical in simplest form, which would be 4 root 3. So just make sure those decimals match up. However, we also have um, variables underneath the radical sign that we're dealing with. So I've got 5y's under there. And what you want to do is you want to circle um, the y's in pairs. So the index is a 2, so you circle your pairs. And for each pair, you're going to cross them out and take out 1. So I take out a y, take out a y, and I would have 4y squared would be coming out. So 4y squared square root of y. No, square root of 3y. And that would be your answer. This one here, many of you could actually probably visualize this in your head. You'd have 9 C's. Edie, you would circle them in groups of what? Nope, not for this one. In groups, oh, I see what you're saying. In groups of 4, yep. For every group of 4, you would take out 1. Marco, can you look at that and just say what the answer would be? So you got 9 y's, circle them in your head in groups of 4. Yep, that would be the answer. C squared, and then multiplied by the 4th root of c, right? So you'd circle a group of 4, a group of 4, and there'd be 1c uncircled. So that would be your answer. This one we won't do. This is more of a 10C question. Okay, let's quickly look at how you would do the reverse. So A would have been from 10C. You're given a mixed radical and you want to do an entire radical of its equivalent form. You need to get that 7 underneath the radical sign. However, you can't just put it in as 7 times 2, because how do you get the 7 out? Well, it needed to be a 49. So remember that the invisible index is a 2. So what you're putting underneath is a squared, or 7 squared, which is 49. 49 times 2 is 98. So this is equivalent to the square root of 98. And again, you would type in and verify in your calculator 7 root 2, root 98, they'd be equivalent. We want to get this a to the 4 underneath the radical. So in order to do that, a to the 4 in a bracket, and we're going to square that times a. That would give you a power to a power is multiply times a to the 1. And this would be the square root of a to the power of 9. For this one here, that 5b is going to go underneath, and we're going to cube it. So it's going to be 5b cubed. You keep what's already there, so 3b squared just stays. What you would have is the 3rd root. 5 to the power of 3 is 125. 5 times 5 times 5. B cubed. And then there's a 3b squared. And then collect your like terms. 125 times 3 is the third root of 375. And like terms, Scarlett, how many B's would I have in my radicand? B5. Let's just add one that I know we talked about. So just a very basic one. Negative 2 and the square root of 5. Do you remember doing this one? Tessa? That's right. So I cannot put a negative underneath my radical if my index is even. You can't take the square root of a negative number. So what I need to do is I'm going to rewrite this as negative 1 times 2 root 5. Then that's going to equal to negative 1. And I'll show you what some of you might be thinking. Okay, so we're going to have this. So our answer is negative square root of 20. Some of you will be saying this. Well, I can put that why can't I do this? Negative 2 in a bracket squared, it's going to eliminate the negative times 5. Why can't I do that? That will give me the square root of 20, same number. So what's wrong with this? Is this equivalent to negative? No, this is going to give me a negative answer. So I need to get an entire radical that's negative. That's why that negative had stayed outside. Okay. Okay, let's combine like terms. Let's just do one of these. Let's do B together. Okay. So 27, simplify. So the negative square root of 27 is going to be equivalent to negative 3 square root of 3. This is already in simplest form. 80 is 2 and 40, 2 and 20, 2 and 10, 2 and 5. So Isaiah, what is the square root of 80? Negative 4 root 5. Yes. And then negative 2 root 12, 2 and 6, 2 and 3. Izzy, negative 2 root 12, what will that become? Negative 4 root 3. With radicals, we then do like radicals. So the like radicals in this example would be the root 3's can be combined. And remember what we do when we add or subtract radicals? You only deal with the coefficients in front. So this will be combined together to give me a root 3. And then to figure out the coefficient in front, it's negative 3 minus 4, which is negative 7. The other like radicals would be the root 5's would go together. Dealing with the coefficients in front, 3 minus 4 will be minus 1 root 5, and I could just write it like that. That is the answer. A couple other ways this answer could be expressed. This answer could be expressed, this would be the same as negative 5 minus 7 root 3. Somebody might write it like that. Or, do you know one other way we could express this answer? Tessa? Take the negative out. So I could have factored out a negative, and then Tessa, what would I have in my binomial bracket? Yes. Yep. Okay, let's review multiplying radicals. And let's do C, and then let's do a conjugate question to remember what the conjugate was. So these are two binomials, and remember that we're going to do the distributive property. So we're going to multiply this times this, and this times this. Oh, first look at your radicals and see if anything could be reduced. So before multiplying radicand by radicand, I would say I can't reduce the 2, I can't reduce the 5, I can't reduce the 10. Over here, if we were doing this one, I'd be reducing the 28. Okay? So 8 times 9, you multiply coefficient by coefficient, so we're going to get 72. And then multiplying radicals, you multiply radicand by radicand. So 2 times 5 is 10. And then next, I would go to 8 times 6. 8 times 6 is 48. And again, I multiply radicand by radicand. So 2 times 10 is 20. Minus, I'm going to do this multiplication here. 5 times 9 is 45 root 5. And then negative 5 times 6 is negative 30 root 10. Jevin, which one do I need to simplify? 48 root 20 needs to be simplified. So 20 is 2 and 10, 2 and 5. Hans, what does 48 root 20 simplify to be? Yep, 96 root what? Root 5. And then put your like radicals together. 96 minus 45. What are you getting? 50 root 10 and root 10. 72 minus 30 is going to be 42 root 10. Okay, so that's how we multiply radicals. You will very likely see a conjugate question. So let's do 6. We'll just put that as E. I've uploaded the key for this, so if you want to do any of these additional ones, you could do those when you're studying. But let's do 6 root 3 minus 2 root 8. No, I won't do root 8. 6 root 3 minus 2 root 5 square. No, it can't be squared. It would be a conjugate. So it would say, what's the conjugate of 6 root 3 minus 2 root 5? Yes. The conjugate of 6 root 3 minus 2 root 5 is 6 root 3 plus 2 root 5. There's a shortcut that you could do if it's a conjugate. And the shortcut is first term times first term. So 6 times 6 is 36. And then root 3 times root 3 is just what? Is 3. Remember, you don't have to do root 3 times root 3 is the square root of 9. Root 3 times root 3 is 3. If I said what's root 17 times root 17? 17. Okay, that's your, and then it's last term times last term. So negative 2 times positive 2 is negative 4. Root 5 times root 5 is 5. This will be when we review, is it in this? Oh, actually, it will be next. I've got the conjugate stuff in here. Okay, so that's how you do a conjugate question. Okay, dividing radicals. So what we want in math is we want to rationalize the denominator. And that means we want to get rid of the radical in the denominator. So let's do B and let's do C together. So for B, 4 square root of 5n, 3 root 2. So we basically want to get rid of that square root of 2. So we're going to multiply top and bottom by root 2. This is how we rationalize. I'm not changing anything because root 2 divided by root 2 is 1, right? So I'm just rewriting this. This is going to be 4 times 10, square root of 10n over 3. Root 2 times root 2 is 2. Instead of multiplying 3 times 2, I'm actually just going to simplify here. 2 goes into 2 once, 2 goes into 4 twice, and I'm going to get 2 root 10 over 3. I'm missing my n. Okay, this one here, how you will rationalize if you have a radical, if your denominator is a binomial, this is where the conjugate would come in. So it wouldn't tell you on a test, it will not say multiply by the conjugate. What the question would say, it would say rationalize. And then it will give you this question here. It just means rewrite this question without a radical in the denominator. So binomials deserve brackets. Let's multiply our denominator by the conjugate, which is the square root of 5 minus 7. And let's multiply the numerator by the conjugate, which is the square root of 5 minus 7. In my numerator, I'm going to have 11 root 5 minus 77. And in my denominator, I'm going to have the conjugate. I'm going to do the shortcut. Root 5 times root 5 is 5. Negative times a positive is negative. Be careful here. 7 times 7 is 49. My numerator is 11 root 5 minus 77. And my denominator is negative 44. This is the answer. However, they'll often do a couple of things. What can I do to this numerator? Do you know what can be done with the numerator? Yes, the numerator can actually be factored. So they may factor the numerator. So each of these terms can be divided by 11. I want you to factor out an 11. So they could do this, 11, and then that would give me root 5 minus 7 over negative 44. And then what's the last thing that they will often do for like a solution? Do you know what the last thing would be? Yep, that's right. They often won't write negatives as a final solution in the denominator. So I can move this up here. This question could be checked on your calculator. These two should be equivalent if you did it correctly. Yes. Oh yes, let's reduce this even more. 11 goes into 11 once, and it goes into 44 4 times. Yes. Okay, I'm going to show you the example of when that's the case. This right now, I'm just dealing with this. I'll show you the example of exactly what you're talking about. But these, because here's the reason why. This is really could be rewritten as negative 11 over 44 times this. Yes, it's its own monomial. I could reduce this. Okay, I'll show you the other example after. So this gives me negative root 5 minus 7 over 4 as a final answer, which is very different from what we had up here. Yes. From which step? This one here? Yes. You could have from there. Yes. Yes. Bring it up. You're negative. Yeah, because if this was a multiple choice question, all of the choices, A, B, C, and D, none of them would have negatives in the denominator. They're going to always move them up, and they might not even have the negative out here. They might distribute it inside. They might actually give this as an answer. 7 minus, do you guys agree that this would be equivalent? Right? It'd be negative 5, which I've taken care of down here, and then negative times negative 7 would be 7. So actually, this is probably the answer they'd get to. Okay, let's quickly talk about what Gabriel was saying. So write this down and let's reduce this rational expression. So let's say we had 2 root 3 minus 8 root 5 over 10. I could factor out the 2, Gabe, and then divide the 2 and the 10. Or I could look at the number, the 2, the 8, and the 10, and I could say 2 goes into 2 once, 2 goes into 8 4 times, and 2 goes into 10 5 times. Okay? What I wouldn't be able to do is if I had this, if I had 2 root 3 minus root 5 over 10, this can't be reduced because in front of this 5, I have a 1. So my numbers here are 1, 2, and 10. 1's the lowest factor. So this could not be reduced. This one could be reduced. Okay, let's review solving radicals. I'll tell you right now, I haven't seen the exam. Every year, they put one of these on as a long answer question. Can you algebraically, and it will be algebraically solve, can you state the restrictions? So we're going to algebraically solve, then I'm going to show you how you could have just plugged it into your calculator to get the answer, and I'll give you about 5 for homework that you could practice algebraically solving. Okay, let's talk about the restriction first. So the restriction is you could never take the square root of a negative number. So what we're going to do for the restriction is you circle your radicand, and you always set your radicand, whatever radicand I give you, greater than or equal to 0, because you can never take the square root of a negative number. You are then going to solve for x. So 2x is greater than or equal to 1. X is greater than or equal to 1/2. This is what we call our restriction on the radical. Okay, so the restriction on the radical is x could be any number greater than or equal to 1/2. So basically what that means is pick any number greater than 1, you plug it into this radicand, and you're going to get a number that you could square root. If you pick any number less than this, so let's say I pick 0, right? 0 is not greater than 0.5. Watch what would happen. I'd get 2 times 0, which is 0, and then I'd get -1. I'd have the square root of -1. We can't take the square root of a negative number. So that's the purpose of a restriction, okay? Now, a couple things I want you to know about restrictions. Let's say your exam gives you this radical. So let's change it slightly. 10 minus 2x. Or do I want, yeah, let's do 10 minus 2x. What's the restriction on this? So take the radical, sorry, the radicand. You always set it greater than or equal to 0. Do you guys know why I chose this one? Yes. So negative 2x is greater than or equal to negative 10. You're dividing both sides by a negative. When you divide by a negative, you must flip your inequality sign. So x is less than or equal to 5. That's the restriction. Now, the second thing, so chances are, if they were going to give you this restriction versus this restriction on a final exam, it'd probably be this one because a whole bunch of students would forget to flip the inequality. Second restriction is, let's just say that they gave you a shape and that they said that the length of the shape was exactly what I gave you. And then you told me, and they said, what's the restriction on this radical? And it's going to be a long answer question, and you say x is less than or equal to 5 is your restriction. You actually wouldn't get the mark. Does anybody know why you wouldn't get the mark? If it's a shape? Jevin, what do you think? It can't be equal to 5 because if it's 5, you're going to get a length of 0, which is not possible. And it also can't be something else. It can't be a negative. You can't have a negative length. So this is the restriction on the radical. However, if it was a long answer question and they gave you a shape, you would say, this is the restriction on the radical. However, it can't be equal to, so I'd erase this guy, because that would give us a length of 0. And then you would also say it can't be a number less than 0 because we can't have negative lengths. So we can't have a 0 length and we can't have negative lengths. So you would just explain that in a sentence. Okay, let's solve the radical. How we solve a radical is 2 steps. Step 1 is isolate your radical. So I want to get the radical on one side by itself. This is how we algebraically solve, which is how you'll have to be able to do it on the exam. So I minus 5 and I minus 5 from both sides. I'm going to get the square root of 2x minus 1 is equal to 12 minus 5, which is 7. Alex, do you remember what step 2 is? I need to get x by itself, but I got a square root that I got to get rid of. Square both sides. This guy in a bracket and square it, this number. I know it doesn't seem important. You're like, well, does it really matter that I put 7 in a bracket? Yes, because let's say that this was negative 7. You want the answer to be 49 and not negative 49, okay? So 2x minus 1 is equal to 49. Now we can get x by itself. Add 1 to both sides. 2x is equal to 50. Divide both sides by 2. X is equal to 25. Okay. There'd probably be a mark for verify if this was a long answer. So tell me what you're verifying. We're verifying x is equal to 25. Remember, you verify both sides. You plug it into the original equation. So the left side is 5 plus the square root of 2x minus 1. So 2 times 25 minus 1. That gives me 5 plus 25 times 2 is 50. 50 minus 1 is 49. 5 plus 7. Principal square root is the positive answer, and that is 12. The right side had 12. Since left side equals right side, x is equal to 25 is a solution. If they did not equal, what would it be called? An extraneous root. So if left side does not equal right side, you write x is equal to 25 is not a solution. It's called an extraneous root. Now, in 30-1, you're not going to algebraically solve radicals. In 30-1, you're going to get your calculators out, and you're going to type in y1, and you're going to type in y2. You're going to recognize that this would be a horizontal line going through y is equal to 12, so that tells you how to adjust your window. Okay. Now let's type this in to get the solution. We really will have to adjust our window because our solution was 25, so we're actually going to have to adjust our x's as well. But let's see what it would look like. In y1, 5 plus square root of 2x minus 1, and then 12. So window, hopefully many of you would see that you would adjust your y, so to 15. Some of you wouldn't see initially, you know, x could be an answer between 0 and 10. So a lot of you would just graph it from here. And then that would, hopefully you'd say, okay, I know it's going to intersect. It's going to intersect way over here somewhere. I would, like, without knowing the answer, I would have probably said, okay, I'm going to change my x max to 50 is what I would have done. And I'm going to change my scale to 5 so it's not going up by ones. There's my intersect. And I would do second, calculate, and intersect. And go close to your intersect, and you hit enter 3 times on your calculator. And then there's our solution. What are the restrictions on n in this equation? Again, very basic one for this. I always like, with inequalities, keeping my variable on the left-hand side. So negative n is greater than or equal to negative 5. Divide both sides by negative 1 and flip your inequality. So the restriction is you could choose any number less than or equal to 5. Now this inequality, or this solving, is a little bit more complex. You'll see why there's a couple reasons why. But my radical is negative. So do you know what would you guys do solving this one? Because I could go minus n, but then I have a negative. I guess when we square it, it will become positive. So we might as well just keep the radical where it is. That's minus n. And then you would have negative, I don't need that bracket just there yet. Negative square root 5 minus n is equal to negative 7 minus n. Okay, so one of two things. We could put this whole thing, actually, maybe I'm going to do something different. We could put this whole thing in a bracket and square it, square both sides, and when you square negative 1, it will become positive. But then this binomial is not going to be as nice when I do the distributive property for that one. Do you know what the other thing we could do is, Angelo? Yeah, we could divide this by negative 1, both sides by negative 1, or I could do this. I'm going to bring this radical over to the right-hand side to make it positive. I'm going to add the radical to the right-hand side to make it positive, and then I'm going to bring this negative 7 over here and this negative n to the left. That's just what I'm going to do. Because sometimes students, when you divide by negative 1 over here, they're going to mess up somewhere. So just in case, let's bring this negative 7 over here. Let's bring this negative n to the left. And then let's add that radical, go plus square root of 5 minus n, and then it becomes positive over here. Now my radical is isolated. To get rid of the square root, you're going to square both sides. On the right-hand side, I've got the radicand, which is just 5 minus n. On the left-hand side, I have 7 plus n times 7 plus n, and I have to do the distributive property. So do not take that 2. You are not allowed to do this. You have a binomial squared. So I will have 49 plus 7n plus 7n, which is plus 14n, plus n squared. We need to solve for n. As soon as you see a square, you tell yourself it's probably going to be a factoring question. That means everything goes to one side of the equation. I go to the side that makes my n positive because I don't have an inequality here. I'm just going to straight factor. I'm going to go to the side that makes, I'm going to keep this on the left-hand side. So I'm going to have n squared. I'm going to add n and add n to give me 15n's. And then I'm going to minus 5 and minus 5 to give me plus 44 is equal to 0. And then I'm going to factor. Who's got the two factors? Isaiah? N plus 4 and n plus 11, yeah. I've got two answers. Do you think they're both going to be solutions? So what you would have to do is you would have to check both of these and just write down, like star this somewhere. So check both solutions in the original equation. Always the original. So you basically would have two verifies that you would be doing. If you do that, what you would see is this solution would verify. So that is a solution. This one would not verify. This would be extraneous. Just to quickly show you why it wouldn't verify, I'm going to plug in, let's just do negative 11 on the left-hand side on our calculators. So on our calculators, n is negative 11. So negative 11 minus the square root of 5 minus n is negative 11. And I would get negative 15. I'll quickly show you on the calculator how negative 4 would verify. Negative 4 minus square root of 5 minus negative 4. Negative 7 would equal negative 7. Everybody's good? If you could not solve this by factoring, and it was an algebraic question, what are you going to be doing? The quadratic formula, which is on your formula sheet. Okay, so I won't do it with you. It's in this, like my note package. Last year, I think I made the students say, I said, okay, take this equation and solve it using the quadratic formula. Make sure you get these two answers. So that's something that you could do to practice as well. Okay, that is radicals. We don't need to do that. Are these in your note packages? Okay, you guys, these questions are probably here because they're just really good exam questions. Either questions that we did in like that were on your exam that I might have just screenshotted. So what I would do is you want to do these. I've uploaded the solutions. So you want to do this one, you want to do this one. You want it this, oh yeah, they were from your exam this year. This guy and this one. This was a numeric response 3. Graph y1 equals y2. If you get a numeric response radical, you can graph. get your answer.